Okay, so last lecture we were talking about the arrays, okay, and we discussed the arrays. We took a lot of examples. By the way, arrays is not included in Thursday's quiz, okay, but we'll continue with the discussion since you don't have questions. So this is 3.1, okay. Just give me 1 second to start the lecture, the presentation, because it's on the drive, so it may take some time. Perfect. So this is our last lecture, and we explained everything here, and we I'll go through it very fast. Just to remind you, we talked about the arrays, and we say the array is, I think I need an empty space. All this was covered. Let me just explain something to you, or to summarize the lecture here. To summarize the lecture, we talked about arrays, and we say the array is a group of variables, okay, that have the same name. For example, I can define integer a of 3. That means they have the same name a, but with different index, and we say this is called index. Okay, so for example, I can define integer a of 3 equals 1 to 10. Okay, this is initialization of the array. That means a of 0 is equal to 1. This is, by the way, the first element. When I ask you about the first element, it's not a of 1. No, it's a of 0, because counting starts from 0, 1, and 2. All right, then a of 2 is equals to 2. A of 1. A of 2 is equal to 10. So if I give you if I ask you print the second element. The second element here is 1, 2. This is number 2, but actually the index is 1. So you will print a of 1. Okay, because arrays always start from 0. So this is the basic idea about the arrays. The other thing, that if I define integer a of 3, as we said, equals 1, 2, and 10, the same arrays, that means I reserved a location in the memory. Okay, this is the memory. Okay, integer. By the way, the integer is 4 bytes. Okay. We discussed several times that it might be 2 bytes or something, but in the system that we are using now, it's 4 bytes. So that means I'll start a of 0. Here 4 bytes. I reserve 4 bytes. This is 1, 2, 3, 4 bytes. Okay, to save the number 1. So here I will save 1. That means also the next one will be a of 1. I'll save 2. A of 2. I'll save 10. All right. That means I'm reserving or booking a set of memory locations to save the array. So that's why if I want to know the size of the array, I can find the size of the memory, this size of memory, and divide it on the size of the type. Now, suppose that I'm talking about float or double. So let's say float. A over 3 equals also 1, 2, and 10. It's the same idea, but it will reserve different number of bytes. Okay, so last thing we were talking about is the size of the array. So if you here, we don't need the pointers now. We'll talk about them later. Also, this one moved to the new lecture. Here we are talking about the size, number of elements. All right. So I'll remove this. Okay. So here it's required to write a code that finds the number of elements in the array. As I told you, suppose that you have this array, this memory location, and this is the size of the type. If we are here, for example, integer, that means 4 bytes. Okay, the size is 4 bytes. So here I have a of 0, a of 1, a of 2, and so on until, because here I have 0, 1, 2, 3, 4. No need to skip it. A of 3 and a of 4. I have instruction which is size of. When I ask the computer to give me the size of A, it will give me the number of bytes. And remember that every integer has 4 bytes. So let's go and implement it practically. Okay, we have here 4 elements or whatever. All right, so I'll increase the size, include stream using namespace std integer main. Again, by the way, this part I can just copy and paste it, but intentionally I'm writing it several times just to make you aware of it and familiar with it, sorry. Okay, so here I'll define integer a of equals 1, 2, 3, 4, 10. How many elements? 1, 2, 3, 4, 5 elements. I'll make them. Okay. 5 elements. As we said, here we have 6 elements, right? So if I put C out, size of the size of the array is size of A. Okay, it will not give me the number of elements, by the way, here. It will give me the size in bytes. Okay, so here I can write bytes. I'll give some space and \n. That's it. Okay, let's run it and see. All right, so if you can see here, it gave me 24 bytes. Okay, but I want the number of elements. So if I have this already, okay, if you can see here, I have the size of the array 24 bytes. Okay, but every element is an integer. And I know that if I don't know, of course, I can find it. The size of the integer is 4 bytes, right? So if I divide 24 by 4, I will get 6, right? But what if the type is different? Then I have to use different number here. So to avoid this, it's better to write size of A divided by size of course, A of 0. Since it's array, it has to have A of 0. The first element. Of course, I can use A of 1, A of 2, A of 3, but sometimes if the size of the array is 1, then it will be having only A of 0. So A of 0 for sure is there. No need to worry. But if I put A of 1, A of 2, and the size is 2, that means the maximum is 1, and you'll get an error. So let's try something before. See the size if it's double. Remember that here we got the size is 24 bytes because it was integer. Let's see the double. If you can see here, 48 bytes. That means the double size is, who can tell, is 8 bytes, correct? Very well. So I'll go back to integer. And also, I will add something. See out the size. Here, I don't know why I have n. Sorry. The size of the integer is, I can write size of A also because it's integer. Okay. Bytes and backslash n. Semicolon. All right, or the size of the integer. Okay, now here. Let's see. Let's execute it and see. But here I have to close this one first. And A of 0. Okay, let's run it and see. Okay. Just give me 1 second. Let me fix things. All right, so I run it again. Okay, so here the size of the array is 24 bytes. The size of the integer is 4 bytes. If I divide 24 by 4, I'll get the number of elements is right. Here also I will write it. See out the number of elements in the array is what? Size of A divided by size of A of 0. Okay. Of course, here we are not talking about bytes. Here we are talking about elements. Okay. And just give me 1 space. All right. So the number of elements in the array is this. Here I will change it, instead of integer, I'll change it to the size of the type of the array. Maybe I'll change it. All right. So let's see. Now, the first thing is the size of the array is 24 bytes. The size of the type of the array is 4 bytes. per element. The number of elements of the array is 6 elements. Now, if you add, for example, I add another element. Let's add, let's say 56 and 34. All right, and see how many elements we'll be having. Enter the number. Stop. All right, so this is what we got. The size of the array is 32, the size, then I have 8 elements. Now, if I change the type, I'll change it to float. Okay. Again, I'll see, I think the float also is 4 bytes. The float also is 4 bytes. Okay. Also, I have 8 elements. I'll change it to another type, which is double. And with double, we say 8 bytes. Okay. So I got also 8 elements. So this simple code will give you the number of elements in the array. So this is, by the way, is very important. Why? Because in C++, not like other, like Python, for example, you need to pass the number of arguments, the number of elements in the array before passing to a function. Okay, so you need to have the number of elements in the array when you pass it to. So I'll add this to your lectures also, or you have it already. I don't think you need it. Okay, this is what you have. Now the other part is multi-dimensional arrays. Okay, so just give me 1 second to start the lecture. All right, so this part will talk about multi-dimensional. Till now we just talked about one-dimensional array. Now we'll talk about multi-dimensional array. Usually the most commonly used multi-dimensional array is two-dimensional array. So what's the multi-dimensional array? Now, till now, as I told you, we just used one-dimensional array, which is, for example, I use the same example, integer a of 3 equals 1 to 10. That means a equals 1, 2, and 10. And remember this in mathematics, right? Now, I need to think of two-dimensional array or multi-dimensional arrays. So write a program that define and print an array of 2 times 3. This is very important, by the way. Here it's important to know about the multi-dimensional array. Multi-dimensional array can have more than one dimension. Just like this, I have 2 dimensions, right? 3 dimension, of course, it's possible to imagine, but more than 2 dimensions, it's not possible to imagine. So array can have more than 1 dimension. 2-dimensional arrays are widely used. In 2D array, we have rows and columns. We call these are rows, okay? And these are columns. All right. So I have 2 counters. In order to print them, to manipulate with them, I should have 2 counters. We will see how to deal with them. 2 by 3 arrays. When I write it like this, 2 by 3, that means I have 2 rows and 3 columns. That means this is 0, 1. This is the 2, and 0, 1, 2. This is the 3. So if I give you, for example, 5 times 7, you can understand that I'm talking about 5, 0, 1, 2, 3, 4. Okay, and here I'm talking about 0, 1, 2, 3, up to 6. Okay. So in this case, 2 by 3 array. Of course, here I will have the array name, for example, a of 0 brackets and 0. Okay, a of 0 means 0 is this one, 0 row and 0 column. This is, I think it's clear. But how about a of 0, 1? Do I mean 0, 1, this 0, 1, or 1 or 0, 1? I'll start from here. Okay, from the rows. So the first number is row. Let me just write here a of I, j. Okay, this is the row and this is the column. The first one is the row and the second one is the column. All right, don't be confused, don't get confused, because you will use to it. Just remember that I'll start from here first, the counting. So that means 0, 2, that means 0, 2. 1, 2, that means 1, 2. 1, 1 is clear. 1, 0, also 1 and 0. I think it's clear. So let's go back to our question. Which is write program that define and print an array of size 2 times 3. Who can tell me what was the meaning of 2 times 3? That means I have array here 0, 1, which is 1, 2 in fact, right? And 3, I have 3 columns, start 0, 1, 2. I have 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, and 1, 2. Okay, so I'll define it like this. By the way, intentionally we or the programmers write the declaration like this one. It's okay if you want to write it directly. If you want to write it like integer a of 2, 3 equals, okay, inside another parenthesis 1, 2, 3, then 3, 4, 5. Okay, it's okay. You can write it like this, but it's better to write it like this just to look like the array. Okay, because the array actually in mathematics or it looks like this: 1, 2, 3, 3, 4, 5. I think you know you in mathematics you call it matrix. Okay, so it's the same thing here. So that's why I wrote it like this. As we said, 2 is the number of rows and 3 is the number of columns. Now, how to deal with them? I need 2 counters here. One counter will move around the rows and the second counter will move around the columns. So for integer I, from 0 less than 2, I plus plus. For integer j equals 0, j less than 3, j plus plus. C out a of ij equals a of ij. Let me just write this code to you, okay, to discuss it easier. So here I'll define array 2 by 3 integer of 2, 3. Okay, and remember, by the way, this in C# and in Python, this has different meaning, so don't get confused. Now that means this is the first dimension and this is the second dimension. All right, equals. I'll open braces, then enter. Okay, tab. Here I'll put the first 1, 2, 1, 2, 3. Remember, between the elements I should have comma. This is a comma here. The second element is, let's say 10, 11, 12. All right. Here I don't want to add comma because it's the last element. All right. So I'll close the parentheses like this. And here I will add space just to make it very much similar to an array. Okay, it's okay. Now you can see here it's very much similar to a regular matrix or array. Now if I want to print them, here I have to add semicolon at the end. Or integer I equals, remember that I will take the rows. So the first row, then I'll start the second row. For I equal 0, I less than 2, I plus plus. All right. Inside this, I have another counter because I will point to this part. So the counter, the second counter will go through the elements one by one. Then after we finish, we'll go to the second row, and the J pointer will go through them one by one. So here I have another counter for integer J equals 0. Okay, less than 3 in this case. Okay, then J plus plus, close it, open and here I want to print, print C out A of I. All right, semicolon, enter. I will add end line. Okay, and here I close the first parenthesis, then I close the second parenthesis, and I'll execute it and see what we'll get. Okay, so if you can see here, after executing this, I got 1, 2, 3, which is the first column, first row, then 10, 11, 12. Okay. Now, there's a tiny modification which makes the printing better. I'll remove this. Instead, I'll add \t. Right, and see what we will get. So I got them like this. 1, 2, 3, then continue 10. What if I can start a new line after 10? That means at the end of this loop, after printing the first row, I can add C out ENDL. Now I think it will look like the original one. Okay, so this is what we got. 1, 2, 3, 10, 11, 12. See, only this minor modification that I've done. Now if I have larger one, let's say of 3 and 4, okay, then in this case I have 3 rows. Okay, I should have another row because 3, and in every row I have extra element. And remember, if I don't put the element, it will take 0. Okay, so here if I say I have 8, give me a number, 20, and 34. Okay, but here also I need to add other elements. Here 3, 4, 10, 11, 12, 13, and here 34. I will add 45. Okay, here also I need to change it to 3, and this should be changed to 4, and That's what we'll get. Okay, we got a lot of errors. The error is here should be a comma, not a semicolon. This is the first error. Okay, so let's run it. All right, still I have more errors. I changed it. I put a comma. No. Comma. Okay, let's see. All right, perfect. So this is what we got. Okay, exactly the same as the array. Okay, so how to deal with the array? By the way, I want you to think of it like this. I will just take the screen. Okay. See what we have here. We have the array looks like this. I'll make it very large just to make it clear. 0, 0, 0, 1, 0, 2, right? 0, 3. Why? Because this is I, and this will be J. Here I have 0, 1, 2, 3. Okay, here I have 0, 1, 2, 3 also. Then here I have 1, 0. Remember, always I'm talking about I, J. And even in alphabet in English, I comes before J, I think, right? Yes. So that's why we are using I first, then J. 1, 0, 1, 1, 1, 2, 1, 3, 2, 2, 0, 2, 1, 2, 2, 2, 3, 3, 3, 0, 3, 1, 3, 2, 3, 3. So always you will deal with them like this. I'll take I equal 0, then J will go through 0, 1, 2, and 3. Then after I finish this, I'll jump to I equals 1, and J will go to 0, 1, 2, 3 again. After we finish, we'll go to I equal 2, and J will go 0, 1, 2, 3 again. So A of ij, okay, every time I put a value to I, J will take all the range of numbers. Now, why I've written it like this? Notice that I have three different regions here. What are the regions that we have? Okay, I'll consider this part. Okay, which is called diagonal. All right, this part here we call it above diagonal, and this part here, for sure you can predict it. It's below diagonal, right? So how to differentiate between these three regions? Actually, it's very easy. If you can notice that, or if you noticed already this, yeah, red is fine. Okay, in this part, I equals J, right? 0, 0, 1, 1, 2, 2, 3, 3. Okay, so I is equal to J. How about this one? 0, 1, 0, 2, 1, 2, 1, 3, 2, 3. Here, if you can see, J is greater than I. Okay, how about this one? Of course, it's very clear that I is greater than J. All right, so in this three cases, if I ask you now, because this is the the discussion. I want you now to write a program. I think the time is off. We cannot write it now, but I'll explain to you. If I want you now to write a program that prints the diagonal. So here I'll do it, and we'll explain it next lecture, of course, in details. But here I'll show you how to do it. By the way, this cannot be done. Why? Because it has to be square. Square array means both are equals, both dimensions. So I have 3 by 3. Okay. Here I can add, if I want to print only the element on the diagonal, which is 1, 11, 34 in this case, then I can put if I equals j, all right, see out, yes, I can't keep it here, see out this, because I have only one instruction. Now let's run it and see it. Okay, so I got here 1, 11, 34. If you can see here, 1, 11, 34 are the diagonal. What if I want above diagonal, which is 2, 3, and 12? In this case, j is greater than I. Let's see the result. Okay, so here, if you can see, 2, 3, 10, 12, 8. 2, 3, no, this is not correct. Okay, I'm sorry, this is 4. It has to be 3. Okay. Run. Yeah. If you can see here, 2, 3, and 12. 2, 3, and 12. These are the elements that were printed. I'll share this link with you, not link, sorry, this code with you, so you can do your experiment. Okay, I'll share it like this, just text, do some change and try to understand it, and we will discuss it next lecture. Any questions? Okay, I'm all set. If you don't have any question, please, you can leave now, and I'll see you next lecture.